We're given two graphs. We're given the graph of f of x equals 2x cubed minus 3x squared minus 2x plus 1, blah, blah, blah. And g of x equals x cubed plus 3x squared minus 13x plus 7. I drew the graphs right here. The graphs kind of look like a, I drew the graphs right here, and the graphs look like a parabola, or like a cubic function this way. And this one kind of looks like a parabola. But the thing about this parabola is it's not really a parabola. You know it's got to be a cubic function. So maybe what it's doing is like way around here, it arches over again. So it kind of has that cubic function look. Maybe we're just zoomed in too much to be able to see the other bend in that parabola or in that cubic function. So we're only seeing the bottom half of one piece of that cubic function, making it look like a parabola. Does that make sense to you? Did I just kind of speak craziness, or did that make sense? Come on, chime in. Say yes, no, I don't understand. What's up? All right. Okay, cool. So check this out. What I want to do is I want to figure out when is g of x bigger than f of x. G of x bigger than f of x. Actually, is that what I want to do? No, I think I wanted it the other way around. I wanted to know when is f of x bigger than g of x. And I guess the second question I need to ask is, which one of these is g of x and which one of these is f of x? Well, I would say that the solid line one is g of x and the dotted line one is f of x. The way I can tell about doing that way is you look at this, I don't really know how to graph something like that. I just graphed that because I had a calculator and I looked at what the picture looked like. But one of the things I do know about this particular function is I know for a fact that it crosses at 1, at positive 1. That's my x-intercept, my y-intercept. So this graph right here crosses at positive 1. That must mean that this dotted line is f of x and the solid line is g of x. I hope I didn't lose anybody at that point. Now what I'm going to do is I'm going to say, well, when is f of x bigger than g of x? Well, over here, on this side over here, it's smaller than g of x. See what I mean? Like, it's the dotted line comes underneath the solid line. In this region right over here, maybe past x equals 1, it looks like the dotted line comes above the solid line until you get about to x equals 2. Now, I'll be honest with you, looking at this graph makes it really hard for me to tell whether or not it does indeed cross. So what I want to do at this point is I'm going to start plugging in some numbers just to see what kind of numbers I'll get. And I'm just wondering, like, what I'm wondering is if it crosses at x equals 1, because that's what the graph looks like to me, but I can't really 100% tell. By the way, this is 1, this is 2, here's 1, here's 2, this is negative 1, negative 2, so on and so forth. I can't really tell whether or not both graphs cross each other at x equals 1. I can tell you that below that point, or somewhere in that region, below all of this stuff below, that the f of x is going to be smaller. But I'm not sure if it crosses right there. So let me try this. I'm going to try to figure out, well, what is f of 1 equal to? What I'm going to do is I'm going to plug in f of 1 into here. So x equals 1. Well, plugging in 1 is very nice because this is x cubed, or 1 cubed is 1. 1 squared is 1. 1 is 1. So that's just basically 2 minus 3 minus 2 plus 1. All right. What is 2 minus 3 minus 2 plus 1? I think that's negative 2. Right? We good? All I did was I plugged in 1 into this point right here. All right. Now, if I plug in, what is g of 1? All right. So that would be 1 plus 3 minus 13 plus 7. Okay. So 1 plus 3. All right, well, 3 of the 13, that makes negative 10. Plus 7, that's negative 3. Oh, hey, that's negative 2 as well. Ah, cool, cool. So I know that at g of 1 and f of 1, that these 2 points are the same. And then looking at the graph, it kind of looks to me like the f of x goes above it. But what I really want to know is, I want to know where they equal to, because I know that's the switching point. And I did it kind of, not really algebraically, but I did it more, I just plugged in a number, I plugged in what I guessed it to be, and then I wanted to see if that was actually indeed true. So the other point that I think that is a switching point is x equals 2. So I want to figure out what f of 2 is and g of 2. And hopefully I'll be able to figure out whether or not that's the other crossing point. So f of 2, plugging in 2 is a little bit harder. That would be 2 times 8 minus 3 times 4, so that would be 12, minus 4 plus 1. All right, so that's 16 minus 12 minus 4 plus 1. Oh, okay, that's just equal to 1. Because 16 minus 12 minus 4, that's 0. All right, we're good. I didn't freak anybody out there, did I? I just plugged in 2 into the f of x. I'm going to plug in the 2 into the g of x and see what I get. So that would be 8 plus 3 times 4, which is another 12, minus 13 times 2, which is 26, plus 7. Okay, all right. So let's see. This is 19. 7 plus 12 is 19. 8 plus 19 is 27, so that's 27 minus 26. That's also equal to 1. Hey, very cool. I figured out the other point at which they cross. So I would venture to say that f of x, looking at this graph, my guess was that f of x was bigger than g of x between 1 and 2. After 2, it looks to me like they cross again, and g of x again becomes bigger. It's very hard to tell by looking at this graph, so what I did was I plugged in 1 into here, and I confirmed that indeed they cross at that point, because at that point they're equal to each other. And if you're going to cross something, then at some point you guys are going to have to be at the same point, and then you guys will cross from that point on. And then they also are equal to each other at point 2. So I would say that f of x is bigger than g of x in the interval between 1 and 2. And actually I put brackets here, but they should be parentheses, because it's not asking when is f of x bigger than or equal to g of x. It's saying when is f of x strictly bigger than g of x. At point 1, f of 1 is negative 2, g of 1 is negative 2. So f of x is not technically bigger than g of x at point number 1. So that's why I say everything except including 1, everything except including 2. But all the numbers in between there, like 1.5, 1.75, all the infinite numbers you can fit in between these 2 points right here, that is your that is where f of x is bigger than g of x. It's like an interval that you're operating between. We cool? Does that make sense? If you want it in set, no, okay, so this is set notation, interval notation. Yeah, to be honest with you, I get confused between the two. I just need to make sure that I understand where this point is. I would say another way to write this would be x such that 1 is smaller than x is smaller than 2. Personally, I like this notation because it's just less to write. I'm lazy like that. Excuse me. Does that make sense to you? Yes, no? Okay, thanks.